Okay.
1 in the morning?
Well, yeah, that's why I go to sleep when I work.
On a school night, you go to sleep at 1 in the morning?
On the nights I work.
Oh my gosh.
That's all I want to read.
It's so late.
I wish your class is not boring because I'll be like sleeping.
This class is just like the only normal class. I feel like it's with the same people.
This is kind of crazy how this one wasn't really that impactful. Okay, so the warm-up question is trying to get us thinking about exponents, and you might wonder why that applies to these first two, but hopefully once you simplify them, you realized it. So there is a very distinct difference between these two. Obviously, one's addition, one's multiplication. But once you simplify them, you get a very different outcome. So you should not have the same thing for each of these when you simplify them. So the difference between these, what do you guys think? So number one, who's confident with what they have? What do you think, Laura?
3x plus 2y.
Yeah, so 3x, there's 1, 2, 3 x's, and then 2 y's. So remember, here we're adding the coefficients. So you add, there's 3 x's total, and then only 2 y's. All right, how about number 2? Yeah, go ahead, Matthew. So this one, with the exponent, instead there's 3 x's being multiplied together, and then 2 y's multiplied together. So again, a very different outcome for when we simplify those. So just be careful with the difference between those adding versus multiplying.
And she said adding.
Adding versus multiplying. Yeah.
I don't know.
It's all about you, Abby. It's okay.
Yeah.
All right. So, and then the difference between are these two. This is one that you want to make sure that you know how to use your calculator correctly. Some of your calculators, if you put this into your calculator and don't put it in the correct way, you might not get the right answer. Guys, those of you guys with laptops open, if you guys can close those, please. So -4 to the second power, what does that give us? Yeah.
16.
What kind of 16? You're right.
Positive?
Yeah, so positive 16. Now, some of you, if you put that into your calculator, if you don't use the parentheses, your calculator might say it's a -16. It's because it tries to do too much thinking. So just understanding that if I put that into my calculator, it's possible it will give me a -16. I want it to be positive because a -4 times a -4 should be a positive 16. So that's how you use the parentheses to make sure it knows to make that negative. If you put it in this way, what it does is it actually raises the power first and then make it negative. So it tries to be like too smart. And then -4 to the third power is going to be, you guys get to that, the -64. And that's okay to get a negative because it's an odd number of negatives as we go there. So we're talking about a bunch of different exponent rules here today. This section, probably in Algebra 1, probably took us like 3 or 4 days, maybe even more. So we're hoping to finish it in a couple days versus like 3 or 4. So we're doing our multiply, divide, simplified monomial, so single terms. We're using negative and 0 exponents, and then also power to a power. So a monomial, what does the word mono mean to you, or that one? So monomial means it's one term.
Isn't mono like kissing disease or whatever?
It's mono. There's like a long word for it. It's mono, so something with a C, but I'm not thinking of the word. Yeah.
Just look up what's the kissing disease.
One term. I had mono in high school.
Oh,
I know.
now you know why.
Yeah.
How do you explain like the colors of the sea?
Let's see why they call it mono.
Yeah. But mono is one. So like you hear like monotheistic, that means that you like worship one God, or monogamous means you have one partner. Like so that you're only dating one person. Terms. One term. Terms are separated by addition and subtraction. So this is an example of a monomial. There's only one term here. Now that might be confusing because there's two variables and there's a coefficient and there's a few exponents, but it only has one term because there's no addition or subtraction. Once I throw addition and subtraction into it, so if I make it, so this is a non-example. This is 1, 2, 3 terms. So this would be a trinomial. So today we're dealing with monomials. So this is not something we're working on today. We're kind of not doing problems like this today. So we're kind of sticking to just the monomials. We use the word constant or coefficient quite a bit. So what's the coefficient in this example? Coefficient in that example?
7.
The 7. So in this problem, it's the number being multiplied to the variables. So 7 would be the coefficient there. When we talk about that, if in terms of like an exponent, 7 would be considered the base. And then what would the exponent be for the 7? I heard it.
1.
A 1. So like a 7 to the first power would be the exponent. And we assume the exponents of 1, bless you, unless they tell us otherwise. But there he sneezed, huh?
Yeah.
All right. So the first one we're going to talk about is the product of powers. Product means what in math? Multiply. So we're multiplying with different exponents. So like for example, 1 a to the third times a squared, what's that going to be? Just remember the rule for this?
Add.
A to the what? Fifth. Yeah. We're going to add the exponents.
Hey, that was like a package deal.
Yeah, you explained it in words. So we add the exponents, so it'd be a to the fifth. 3 plus 2 is 5. I've got example 2 there. Yeah, go ahead. A cubed and B cubed. Because again, we assume there's like a 1 there if they don't write it. So 1 plus 2 is 3, 2 plus 1 is 3. So we get a to the third and b to the third. So that other little bullet point you see there, the little asterisks, we add the exponents, but how about a number 3? What do we do with those coefficients? So like the 3 and the 4. Or what's the r going to be? Tell me something you know about this in example 3. Yeah.
R is going to be 11.
R is going to be 11, so you're going to add the exponents for the r's. And then how about the 3 and 4? It's going to be 12. So what did you do with 3 and 4? You multiplied it. So you treat the coefficients like they are normal numbers. So we add the exponents, but we're just going to multiply the coefficients. So if you guys want to try example 4 there.
Bed.
Bed. You didn't see that in his bed.
No?
Is it yes?
All right. Someone help us out here. What are we going to get in this case? Example 4. What's the coefficient? So 30. So Abby's right. So 6 times 5 is going to be 30. E to the 6th. And D to the 7th. Very good. 30, E to the, you said 6, and D to the 7th. Is this kind of coming back to you?
No.
No. All right, do you guys want to grab whiteboards then?
My algebra teacher didn't
Should we grab whiteboards now, or you want to do dividing right away?
No, let's just do it now. Let's forget about dividing. Let's just do it now.
Abby's the only one up.
There she goes.
How nice.
It's supposed to be 66 on Wednesday though.
Yeah, it'll be nice later this week. We'll go outside one of the nicer days this week. Like today, probably only supposed to be like 50, but. Now, if you guys know we're going to go outside one of these days this week, and you know you're someone who's always cold, then bring a jacket to class. It's 52 right now. But tomorrow's supposed to be 62. Wednesday's supposed to be 63. That's 10 degrees warmer. It's so much nicer. Friday's supposed to be 64. It's like shorts weather.
Heat wave. I thought it said 66, I don't know. The guy on the radio that told the weather, we're warm sometimes.
Okay. So, I wanted to put these two next to each other because they connect so closely. So product of powers is when we multiply, we add the exponents.
No, we're just doing?
Yeah, that's what we just did. Yeah. One more time, one more avenue to get that into your memory.
Oh.
In the highway of your brain.
Who made that video?
I think that was on the, you guys watched that in AR. Miss Hausner wrote like something about that. Like for.
Oh, yeah, he just read it out to us.
Yeah. To mention that. Okay, quotient means we're doing what with them?
Do we subtract?
Yeah, here we're dividing the powers.
No, we're dividing, not subtracting.
But then we subtract the exponents.
I know.
Now, some of you guys had this algebra teacher who probably repeated myself a whole lot, that I would keep saying to you, where are there more A's? Like, are there more A's on the top or the bottom? Top. There's 3 on top, 2 on the bottom. So how many more? You do 3 minus 2. So this would be just a to the first power on top, or just not even in a fraction at all. So we subtract the exponents in this case.
Okay. Everyone got that?
We're going to do a few examples here, then we'll get our whiteboards. Settle down already.
Yeah.
Okay. So we're simplifying here. 12 over 3.
4.
That is 4. Very good. So one of the things that kind of happens with these is we start thinking of these rules, and then we start applying those rules to things that they're not supposed to be applied to. So 12 over 3, Abby just divided those to be 4, or 4 over 1. And we have m to the 4th over m to the 1st. And so this is where I'll ask you guys, where are there more m's?
Top.
Top, how many more?
3.
3.
Someone give me a medal. I'm on fire today. I saw your mom have some on Facebook.
All right. So 4 over 6 becomes, does 4 over 6 become 2 over 3? Now careful here, where are there more x's this time? Bottom. How many more?
5.
5. So I am subtracting them still, but I'm doing 7 minus 2 and just knowing it's going to be on the bottom instead of the top because of the fact that there happen to be more x's on the bottom than the top to begin with. that okay?
No,
Really?
that's fine.
Okay. It's been a hard Monday, Abby, so like, it just felt really like,
I'm just tired.
I like came to school and I'm teaching my class, they're pulling kids out of my class and I'm stressing. Well, yeah, there was people who didn't know they were supposed to be quarantined and they were here.
Oh yeah, I saw Mr. Rude yell at them.
Well, no, like I said to the student, I was like, wait, aren't you on the football team? He's like, yeah, but they only quarantined half the football team. And I was like, oh, okay. And so I just kept teaching. And then like 5 minutes later, Mr. DeBrook came in. So apparently that's wrong. They weren't just quarantining half the football team. It was everyone. So I don't know, that kind of stuff stresses me out. I'm just like, I go with,
I think you should go home, take a bath. Have Mr. Donahue make dinner tonight. There you go. There you go. That's how you should resolve this one day.
I actually went and sat in his room. He's like, what's wrong? And I'm like, I don't even really know. I'm just like grumpy or like sad or something. I don't know. Okay, so I have K to the 7th over K to the 5th. Where are there more K's? How many more?
2.
2. All right. How about the M's?
Bottom.
Okay. M's? Bottom, how many of them? 7.
Did we just say that?
I know, I'm still, someone had said wait, and so I was like
Oh,
waiting.
sorry. Sorry.
All right. What happened to the P's?
They cancel out.
They cancel. They're the same on the top and bottom, so they cancel. It's P to the 0, which is just nothing. So we get rid of that. We just leave it that way. And then finally, and then we get a whiteboard. Yeah. All right. How about the X's? Where are there more X's?
Bottom.
Bottom. How many more?
4.
4. This is only a 1 up there. How about the Y's?
They cancel.
They cancel. So can I leave it this way?
I don't care.
Yeah, put a 1 there.
Oh.
Yeah, put Abby's not grading your test. You need a 1 on the top. All right. Why don't the 2 middle rows grab markers, erasers, or markers like Kleenex? You guys are good at this.
Look, I'm Harry Potter.
Hey, Abby. Yes.
Does Harry Potter do that? I actually never seen it.
There are more of the X's. So here is your little group over there. So there's one.
Excuse me. Sorry. I didn't mean to mess you up.
Yeah.
I'm gonna draw Maggie.
To draw a hand turtle. It's hand turtle.
Oh my gosh, I'm gonna make one for my fridge. Like I used to do back in the day.
Hey, Nick, I'm gonna draw you, right?
24.
I thought it was on the 22nd this year.
24 days to do your Thanksgiving shopping.
That's not happening this year.
I know, we can't quite figure out what we're doing either.
My dad makes ham anyway. They're like, turkeys are gonna be at the store. But my dad makes ham anyway.
I think I like ham better than turkey.
My dad doesn't like brown sugar ham.
Oh, I love stuffing too.
No, gross.
I love stuffing. I love pumpkin pie with whipped cream. I can't have pumpkin pie without whipped cream. If it doesn't have pumpkin, it doesn't have whipped cream.
Stuffing's just not.
I don't like my grandma. What is it, just a triangle?
Was that the Yeah, get my hair. Well, from like.
Are you a ranch fan anyway?
No.
No.
Okay,
not
this is a
from
really
the
good question. Okay, so you know
It's
how
not
like
from the
tomatoes
80s.
super ketchup and like made on
Don't think it's fun.
Do you eat roasted
Oh.
ketchup?
I like grilled cheese.
No.
I like ketchup on a lot of things though. So.
Grilled cheese and ketchup.
Yeah.
I'll put tomatoes on it, but I'm
That's
not.
basically like dipping. I like.
Well, like your burger, you put ketchup on your cheeseburger, so why not on grilled cheese? Oh my gosh.
I'll put tomatoes on it.
No.
Ham, tomatoes, pickles. I'll put that on.
I love making a grilled cheese with bacon on it.
That's good too.
Bacon grilled cheese.
I'm like sensitive to bacon though. Like sometimes it'll go well.
Yeah, I don't like it either.
Okay.
You yelling at me, Kinsey, about how I'm doing my life?
Amazing.
Kinsey will yell at me about how I'm doing my life.
So you're not gonna look at
Why don't we just do that?
Quick.
All right.
You know who Kinsey Bellucci is?
That's not mine.
Okay. You guys could do this one, please. Simplify.
Kinsey, you call Maddie Partman, and that's
Yeah.
not her name.
That's not nice. One time.
Yeah, I don't think it was one. Now I call Maddie that too.
You guys must be way smarter than my class last year. This took us a long time to get through. Yes. Yes.
I mean,
Yes.
I
Yeah.
this, but,
Yeah. What color are you using?
Wait.
Yeah. Oh, good. Now, thank goodness you had that last
Hi,
one.
Mom. She's like, hey, friends in the class.
Oh, that's cute.
And I'm like, are you like a random like? I'm like, I know everybody. Look at the snakes.
That's the big enough.
Wait, let's go with that.
Is this the one?
Ladies.
Cheers.
Baba Booey.
So in this case, you guys,
Oh my god.
we end up with 4 times 2 is 8. X to the third, you add those exponents, x to the 6th, and then y to the 1st, and the 4th be y to the 5th.
Why 5?
Because. All right.
I'm so funny.
Yeah.
I can't do this math.
Hey guys, try this one.
Actually, wait.
Oh man.
Yeah. Yeah, no, you're good. I just couldn't read your coefficient is not quite right. Yes. Yes.
I guess I wrote it sideways.
Yeah. Yeah.
Laura,
Well, your coefficient
how's
is
it
not right.
going? How's it going?
You catch what you did? Yeah.
What about you?
Well, don't do it as a fraction. Don't do it as decimal. Make it a fraction.
Oh,
So the 3/9.
my name is Kinsey.
There you go. Well, no. So the 3 should be a big.
Oh, wow.
So I put the 3 on the top. It's 1/3.
Rattling?
Because like
Oh.
you know, just put it on the bottom. Otherwise, you're like a compound fraction. So 3/9 just becomes
Sorry, Nick. I got you.
3 has to be on the bottom, so we're gonna draw this one. All right, so in this case, you guys, we have 3/9. A lot of you guys just overthought this. So 3/9, heavy. So 3/9, you divide these each by 3. So this would be 1/3. Then I look at the ends. There's more on the top than the bottom. There's one more. So end of the first. And I look at the ends. There's only one on the top, but 6 on the bottom. So there's 5 more on the bottom. So you could leave it like this, or you don't even need the 1 there. You can just have m/3 n to the 5th. It doesn't matter. They're the same. And it looks like a lot of you guys have got this, but then some of you are a little bit shaky on it. Please feel free to ask, and we could definitely go over things a little bit more if needed. But let's try a little bit trickier one here.
Oh, snap.
See how smart you guys are.
Easy, bro. Easy,
I got lost. Whoa. Come here.
This is a shirt I want to get. Kinsey Delwichy told me to.
What was that? It's all shaky, bro.
Because she tells me to do that stuff.
Why shaky?
Baba Booey.
What is that?
Why say hello? Shoot.
You are good, man. Yes. 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 Yes.
Like this.
Yes.
I'm so good.
Your x is not correct.
There's something
Like
wrong.
this.
And your coefficient.
Like this.
What?
Now tell me. Like this.
Hey.
Like this.
Oh, wait. Except there's
Do it like this.
What? Oh, I missed
like this.
Yeah.
It was just a habit of doing it.
You guys messed up. Not quite. So, is this what you had on the top? Yeah. That's good. Over.
I raised
You pull down.
Should we check it?
So, where are there more of the 16 and 4? 16 over 4 is just 4, but then that should be on top. Yeah. And then looking at the x's, where are there more x's? How many more? Yeah. And then the y's are there.
That was one of my favorite performances.
Yes.
Jonathan Draw.
Do you guys want another one?
No.
You're good? Make it simple.
Okay. Come on. No, I love it. So mean. Well, yeah. Rachel. Yeah, I hate it.
Snowman.
That's what I think.
It's snowman.
Phyllis, did you hear Kinsey?
What's that?
She said she is
What? Stop it. I did not say that.
I heard that.
What happened? I did not say that.
Okay, try this one, guys. This is not easier.
Wait, Kinsey, what did they say you said?
They said I hate
They call her the little Asian girl at work.
Yeah. At her job, they thought she was Asian. So all I could see were her eyes.
That's why.
Okay, so guys, in this case, I would suggest just multiplying all the way across the top. You don't cross multiply because there's no equal sign between them.
You suck. What? What do you mean?
You got it. Good job.
What? Yeah, but that.
Yeah.
Well, she's German.
And she's kind of focused compared to the rest of you.
No.
That's exactly. To the 50th, sir.
There we go.
White choice.
They can simplify more.
Yes, sir.
Yes, Kinsey, you're good.
Yes, sir.
Yes, good job.
Yes, sir.
The y is still on the bottom. There's y squared.
Oh, I did it. I did it.
Yes, sir.
Yes.
Over one. Over
And
one.
then it's so simplified. You're like, these can be simplified. You're really yeah, and it's like really where the bigger number is. You're doing it right. There's more. This one here, this will be the first next to the fourth.
Oh my. Put that
I
away.
went down 6 over 3 to divide.
Yeah.
He sounded great.
So you're good. Right here. You're good. Yeah.
And then
How are we doing, you guys? All right, so my question is are we okay to learn something new or do we need more practice of this?
More practice.
Well, I mean,
We're good with this.
well, we are going to go a little bit further into the notes. We'll probably just go to the bottom of the page. Or maybe, yeah. Okay, why don't you guys hang on to your whiteboards? Don't put them away yet. We'll finish the bottom of the page, and then we will we'll go back to whiteboards for a bit to make sure you guys are good. And then that's where we'll stop for today. So we'll just finish this whole first side here, and then we'll wait for part 2. Okay.
Really.
So, all right, guys. So,
Oh, that's so weird.
okay, guys, let's focus here. So, we're talking about power to a power now. So, if you notice, we have something in parentheses that is being raised to a power on top of already having its own exponent. So, that's where the power to a power comes from. Now, we cannot do a problem like this using power to a power. What's wrong with this one?
There's no power. I'm missing a power.
What did we say the title of the section is?
Power to power. I'm missing a power.
The title of the whole section is the M word, monomials. What's wrong with this?
There's no power.
There's 2 terms. This is a binomial, so we're not going to use this rule for problems like this. So I just want to make sure it's clear that if it has 2 terms, you can't use this rule. So that's a binomial. So in this problem, I have a to the third and then to the second power.
Okay.
So any idea what we need to do here?
Multiply.
Yeah, multiplying. If it's a to the 6th power. Now, if you're unsure that you agree with someone who said that, it's a to the third, and it's being multiplied by a to the third. So the squared. So 3 and 3 would be 6. So we're going to multiply the exponents. We're going to multiply the exponents, but when you do that, you're going to distribute them to all the bases. I'll show you guys what I mean in a second. And you're gonna put it on both the top and the bottom. So in this case, like this m is going to be distributed to the top and the bottom. Now you're not going to be able to do much with this because they're all variables. So this is m times n, and then this is going to be over b to m times k. Just multiply those exponents together. Won't seem any like that. So we have this for example 9 there. So how many times does that exponent have to be distributed in there?
Once.
How many different places need to get that exponent?
3.
Yeah, it actually has to go to 3 different places because of all the bases have to get that exponent. So that fourth power is going to go to the 2. It's going to go to the 3, but it's also going to go to that base of the 2. So everything has to get that fourth power. So this is going to become 2 to the 4th, x to the 12, very good, y to the 8th. Now 2 to the 4th, I would like to simplify just because I can do 2 to the 4th power. It's 2 times 2 times 2 times 2. So that's going to end up being 16. So this would be our final version of that.
Bennett. Oh, now you're throwing shade. That was at Kids' house. That was
I listened to
small.
it.
That was Kinsey's phone at Kinsey's house.
Okay, sorry, I was just trying to check on our homework here.
That was your phone at your house. That was Kinsey's
right.
phone at her house.
The next one here, guys, our example 10. This exponent has to go into all the bases. So like in this case, it's going to go here, but then also to the bottom of the fraction, just like we did up here, and then to both of those numbers as well. And then here as well. So all of these are getting that third power. A to what power? 6. B to the 6th as well. Okay, we're not done yet. We're going to do some simplifying first. So 1 to the 3rd power is how much?
3.
It's just 1.
1.
Yeah.
2 to the 3rd is 8. 2 times 2 is 4. Times 2 again is 8. Okay. How about negative 4 to the 3rd power? We just did that in our warm-up.
Negative 60.
Negative 64. It's going to get multiplied there. Talk about that in a second. A to the 6th doesn't have anything to go with. But then b to the 6th and b to the 3rd, what do we do with the exponents there? Add them. So it's going to be b to the 9th. And we're just left, the last thing left to do is to get these two together. 1/8 of negative 64. Negative 8. Very good. She must have whispered it.
Yeah, she's a little quiet. I don't know why.
Because of the standards, you're going to be like, oh.
Okay.
So I'm not going to say anything. I don't want you.
All right.
You
So number 11, and then we'll do a little bit with whiteboards, and then we'll be done for today. And I'm going to alter the homework. So number 11, what do you guys want to do first in this one? We can do a couple of different things. Any thoughts? There's two different ways to go about this, so it's up to you guys for number 11. What do you guys want to do first?
Divide.
Divide. So you can actually simplify a little bit first. Do you guys see what you can simplify there? What happens? The y's actually cancel.
Whoa.
So you can get rid of those altogether and simplify this a little bit first before you get started with the exponents. So the y's can cancel. It makes this a little bit nicer to work with to begin with. Now that 2 has to go in everywhere. But now we have less places to put it because of the fact that we simplified a little bit first. Now, had you not done that, it would have been okay as well. So 5 to the second, x to what power? 10. 6 to the second. And then I'm just going to simplify this or like figure those out. As much as it seems like you should be able to do it, 25 over 36 doesn't simplify at all. Okay?
Good job, everybody.
So, if you guys could grab your whiteboards again, we're going to do some more practice with that. And then again, I'm going to assign some homework problems, but it's going to change the homework quite a bit just because of just trying to skip around and avoid some of the ones we haven't done yet. So,
I still pointed on there. It's not that point. It's nice, it's nice around there. It's not even that big. I mean, it's
No.
okay guys, so you can do this one first. Simplify as much as you're able to.
Here, get that wrong, bro.
Stop. Yeah. I think you're good, Bennett. You can probably see that well. Yeah.
And then
Yes.
Yeah.
Yeah. No to your x. Look at your x again. Yes. Yes.
I do try to find something better.
The only other thing is you could do the third one. So power to a power root. Power to a power root is multiplying. Yeah. Yeah. So guys, on this one, we're putting that power into all of these. And we multiply the exponents so that it becomes a new exponent by multiplication. But then 2 to the third I can do. It's 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. So that would be our final answer then there. Okay.
you don't even know his name. And you love it. I mean, Jordan Fisher might have really.
Okay, so try this one here. So we have power to a power, we also have multiplication.
That's a decimal?
No, it's a times.
Oh, okay. Oh, yeah. I knew that.
Yeah, it becomes just like exponent. Yeah. Yeah, so much on 2 times 5. Your, no, the exponents of the variables is not right. Your x is not right. Your y is okay. Check again. Your exponent is not right. This one is not. The number in the front is not right. The 2 shouldn't be there. No, so it shouldn't be, or you should actually do that multiplication then. Yeah, you're good now. Yes.
Is this 12?
Your x is still wrong. And your y is still wrong, sorry.
Is this 12?
You said it was a
Sorry.
okay.
Oh, that's
Yes. Yeah. The y is not right. The first y never had an exponent there. You see that?
I got that.
Yeah, yeah, you're good. Yeah. Yeah. Only thing is, this is 25, then you multiply by 2. No, that's actually right. Good work.
That's right.
Yeah.
Oh, thank you.
Yeah, that's
6 plus 7 is an 11.
No, it's
now they get it right.
No. So let's talk about it. Okay. So guys, we're distributing this in. And so I get 5 to the second, guys, x to the 6th, y to the second. Then at this point, I make 5 to the second into 25. Now I have to look at what I can all put together. So 25 times 2 is 50. I can do that, it's doable. X to the 6th, x to the 7th. We're adding those exponents because now we're back to the multiplication rules. So x to the 13th, and then y to the 2nd, y to the 3rd is me, y to the 5th. All right, let's do one more.
I never distributed the 2 in.
Oh, in the very first place? Oh gosh, I went to it.
Yeah, I did it.
Okay.
My favorite song.
I had pizza goldfish for lunch.
That's like
Pizza.
Yeah.
Flavored pizza. I think you have it wrong.
But OG goldfish. I never Oh my gosh, you're gonna put ferment and I'm just gonna.
You ever just want to give your next?
You let your brother make fun of my last name. Every time he sees me, he goes, Oliver. Every time he sees me.
Okay, guys.
I think Kinsey wants
The blue one, the new blue one here.
I knew I fell like you and flushed the toilet.
What?
That's my new song for you and Brad.
Stop. I don't know what.
I knew I fell like
Okay, this might need some focus here. This is a little tougher one. Only thing is, I wouldn't want that as a decimal, so I want it as a fraction. You're good. Maybe it's 8 bar, right? 6/4.
Yeah, that's what Kinsey said.
Yeah. Yeah, you're good. Just like that.
Kinsey said that.
Yeah, so simplify that.
Yeah.
I just say 4.
I didn't even
Otherwise, the
hear
rest of
what
it's
you
done.
said.
Yes.
What did you say? I didn't
Yes.
even hear what it was.
You can simplify more. So everything now you're going to do your division. Yes. Yeah. You can simplify it. dividing each by 4.
Okay, is this right?
Close. Why the x up here is 4 times 2, so this should be
I'm so sorry that
Yeah. So, I didn't say.
What did he say? What did he say?
But I hate my own
You're just jealous of Kinsey.
Like you did TikTok?
No. Fight.
Wait, what's the name?
Garrett, shut up.
Yeah. You're good, yeah.
No, they're making nauseous.
Okay. So we're going to distribute this in. So this becomes 6 to the second x. You have to do multiply the exponents of 8 y squared. The bottom, I can put this all together. So 4 times 2 is 8. X to the second, y to the 6th. You add the exponents. Then 6 to the second is going to be 36. And then now 36 over 8, kind of a weird number. It's not a nice whole number, so we need to simplify it. Just like you would simplify a fraction, way back when, like middle school or whatever. So this would become 9 over 2. There's more x's on the top and the bottom. There'd be 6 more. And there's more y's on the bottom than the top, 4 more. And that's our final answer. Okay? So we can clean up boards. And I'm going to assign what our homework is, which is going to be changed.
Hey guys.
What? I'll change it on school days. It's not right yet, because I didn't know how far we'd get.
There we go.
I don't know what you're talking about. Let me look up.
Garrett, you farted on a baby?
You got me.
I got one. Speed.
Oh, sorry guys, it's just kind of all over the place because we didn't get through everything. So just give me a little second here. This will be it.
That's like 45.
It's not like 45 problems. Okay, count them up.
1, 2, 3, 4, 5, 6, 7, 8, 9.
It's under 20.
10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Is it exactly 20?
Yes.
Oh, perfect. That sounds like the perfect number of problems.
I can
I
only
think
do
under
3.
10 is perfect.
So this is due tomorrow.
I can only.
Okay, we have 20 minutes to get working on it, and so a minute a problem, you can be done.
She's better. That's true. 1 minute. The only thing that I noticed, you were talking to your students about, is they said you want to go
Oh, yeah.
I think the whole thing. That's not bad.
You think I'm
Yeah.
Wala, open.
What are the chances?
I'm gonna put this on Schoology. Oh, I need to stop the recording.
Bye.